Once upon a time, there was a man named Johnny. Now, Johnny was a wine manufacturer, and though his operation was based entirely out of his kitchen, he had tens of thousands of wines on the market. Though he loved the taste of his wines, Johnny found himself in financial trouble, since there were, let's just say, mixed reviews of his wines. After pondering for days as to why people were not liking his wines, Johnny began to think that a big reason might be that he can't tell white wine from a red wine, because he was blind. And so, Johnny commissioned the National Wine Consulting Group, or the NWCG, to help him determine which of his 6,498 wines were red and which were white. In understanding this, he hoped to make better recipes with the knowledge of what features are characteristics of each type of wine.
So before proceeding with our analysis, we decided to run an EDA in order to gain a better understanding of the data set, the variables that we were working with, and to identify any underlying patterns and relationships that could help validate the analysis that we were going to run. So first, we looked at a description of the data and figured out that we had over 6,400 observations across all the variables in our data set, which was a good amount to work with. And you can also see over here the mean, the standard deviation, and the overall distribution of all these features. Next, we look at the distribution of wine type in our data set, which is the main variable of interest. So as you can see, the data set is not really balanced along this attribute. We have a lot more observations for white wine than red wine, almost double. And then we also look at the distribution of some of the features by building box plots. So we look at how pH levels are distributed across these two different wine types. We look at how alcohol is distributed, density as well as fixed acidity. And overall, we get the sense that there is some sort of variation when we're looking at all these different attributes divided by the two different types of wines. But again, we're going to confirm this before we actually proceed. So we look at alcohol levels and compare them across red and white wine by running a t-test. So before running the t-test, we confirmed that the variance is homogeneous across both types of wines. We also confirmed by building a histogram, we confirmed that the residuals of the variable that we're looking at are normally distributed. So because the assumptions are met, we can run a t-test. And once we actually run the t-test, it appears that the two different wine types actually have statistically significant different levels of alcohol, which is promising because it does provide some indication that we can use this feature at least to compare the two different wine types. So as you can see over here, the p-value is pretty small, which means the result is statistically significant. We also run this for pH levels. Again, we can confirm that all the assumptions are met, and then we check whether pH levels differ between the two different wine types. And again, we have a statistically significant result. So we know that this is something that we can use to compare. I haven't shown all the results over here, but we do run these t-tests for all the different features in our data set and find statistically significant differences along all the attributes, which means that the features in our data set can be used to classify these two different wine types. Then we perform data pre-processing. So we divide the data into training, testing, and validation data frames. We remove the identifiers and impute missing values. We encode the categorical variables, and then we scale the data before proceeding.
Now that we have done our exploratory data analysis as well as our data pre-processing, we can now begin the model build. The question at hand here is a wine red or white? And because of this makes it a binary variable. To predict and classify this binary variable, we're going to deploy 6 different models and see which one performs the best. The classic binary model to use statistically would be the logistic regression, which we learned in the beginning of the course, and this will help us find a strong probability as to each entry in the test set being a red or white wine. We'll also use both decision trees and random forest to calculate the same types of probabilities. And we'll also use histogram-based gradient boosting classifier as well as XGBoost classifier. These gradient boosting techniques will be very integral in determining feature importance later on. And finally, we're going to deploy a multi-layer perception classifier. This neural network will really help us optimize the stochastic gradient descent, but also more importantly, help us determine which features are most important in the data set for determining wine type. After deploying all these methods, we find that the histogram gradient boosting classifier has a 99% accuracy in predictions. And in all honesty, all of the models that we have are extremely high in predictive power. After histogram boosting, then is MLP, followed by logistic regression, and so on and so forth. But we have incredibly high accuracy here, and that makes a lot of sense. The two wines are different, and if you didn't know the color, there are several chemical properties that give them those colors. The color, while it is the easiest thing to point out, it is, if you didn't know the color due to blindness, you would be able to determine the wine by its chemical properties. Of the models that can provide feature importance, we look at XGB classifier, the highest performing model that can do so, and we see that total sulfur oxide and chlorides have a strong impact on what kind of type it is, red or white. Over 25% for both of them, actually. So this can tell us that in knowing these two things, most of the explanation as to which type it is comes down to these two things. So having a numeric value for this can very strongly point you towards which type of wine it may be. And in looking at all this together, we can use this model moving forward to classify a wine as red or white and no longer have to worry about the confusion between both. Interesting. So based on these models, it seems like total sulfur dioxide and chlorides account for over 50% of the importance of the model, which means that these two things strongly determine if a wine is white or red. I really should have paid attention in that winemaking class. But now that I know this, I'll be able to change the world. I'll be able to make the best wines on the market. Yeah!